everybody, we're in section 1.4 and we're going to be looking at measure and classifying angles. So we're going to measure and classify angles today. Write today's date and let's get started with the information. Our first word is angle, and we've got a little picture here, and we're going to define an angle as follows. So an angle consists of two different rays with the same endpoint. When we talk about that endpoint, that brings us to like another vocabulary word, and that word is vertex. The vertex is going to be the actual endpoint that those two rays share that creates the angle. So that's what our vertex is. So again, the endpoint that is shared by the rays that create an angle, that is what we would refer to as the vertex. Another word for these rays would be the sides of the angle, the sides of the angle. So we've got vertex and the sides. And remember, the sides are the two different rays that make up that angle. So let's get on to the different types of angles that we can have. So we can have an acute angle. An acute angle looks like this. It's an angle whose measure inside is going to be less than 90 degrees. That's an acute angle. In addition to that, we also have obtuse angles. Obtuse angles are angles whose measures would be greater than 90 degrees, but less than 180 degrees. So that's greater than 90 degrees, but less than 180 degrees. We have another angle we're going to talk about, and that angle is a straight angle. A straight angle is an angle whose measure is equal to 180 degrees, and so it's often going to look like that, a straight line. That straight line with a vertex there to indicate that we're actually dealing with an angle. One angle that I probably would have given you before this one would be a right angle. We did talk about right angles today, not today, this week when we were dealing with the Pythagorean theorem. So the next one's right angle. Let's write that down. And that right angle is an angle that has an angle measure of 90 degrees. And I think you guys are familiar with that as well. So that's the different types of angles that we're going to talk about. We've got a couple other vocabulary words associated with the angles and two postulates. So let's write those down. Make some space. I'm at the end of my page and we're going to need some space for our notes. So I just want you to be very careful in your writing. What we're going to write right now is the notation for naming an angle and its measure. So I want you to take a look at the following and just be careful with what we're doing. So let's draw an angle. I'm going to start off with an angle and I'm going to name some information on this angle. So one, I'm going to call this vertex point, point O, and I'm going to call one point on this ray P and the other point on this ray Q. So when we talk about an angle, if I have an angle just hanging out by itself like this, I can call this angle O and I'd write it like this. When you see this symbol, it means angle, and this is the name of the angle, angle O. It's only sometimes I can name an angle with one letter. Generally, I'm going to use three letters. So in this case, I'm going to use POQ. This is another way of naming this angle. I can call it angle POQ. I could also call this angle QOP. I cannot call it anything else. Meaning, if I were to call this angle, let's say QPO, I wouldn't be talking about this angle because when I say angle QPO, I would be talking about this angle right here, QP and then O. This is what that means. So there's an order to this thing and I need you to pay attention. The vertex of the angle, that's this guy right here, which is very important, always needs to be in the middle. So this is an acceptable way of referring to this angle, QOP. This is an acceptable way, POQ. And if the angle is alone and there's nothing else, no other rays coming out from the vertex, calling it angle O is sufficient. So these are the only proper ways to refer to this angle. Let's get rid of that. If I want to refer to the measure of this angle, like the degree measure, I would put a little m beside the angle, name the angle, so I can be talking about the measure of angle O, or I could talk about the measure of angle POQ, which is still the same angle, or I could talk about the measure of angle QOP. Again, still the same angle. So the little m means that I'm looking for a number, not just naming it, but I'm talking about the value of the measure of that angle. So our next phrase or our next word is congruent angles. Let's say I had these two angles and I found out that the measure of angle CDE was equivalent to the measure of angle BAT. If these two angles have the same measure, then they are congruent angles. And so this, what I'd write this, or how I'd write it when I'd say that they're congruent angles, is like this. So this says that angle CDE is congruent to angle BAT, whereas this says that the measure of angle CDE is equal to the measure of angle BAT. You need to have this in order to have congruent angles. So again, when we have two congruent angles, we start off with angles that have the same measure, and if they have the same measure, then we can say that those two angles are indeed congruent. Before we get to our postulates, let's talk about this angle bisector. An angle bisector is going to be a ray, and it's going to divide an angle into two congruent angles. So let's go ahead and demonstrate that. Let's say we have this angle here. We start off with this angle. We could even name this angle CAT. If we were to take a ray that comes out from the same endpoint, and that ray is positioned such that it splits angle CAT into two congruent angles, let's call this ray AR. Then we now have angle CAR is congruent to angle RAT. If those two angles are congruent, then we can say that ray AR is an angle bisector because it broke the two angles into congruent angles, into two congruent angles. Does that make sense? All right. So again, AR is an angle bisector if CAR, if angle CAR, is congruent to angle RAT. All right, we've got a couple of postulates. Let's go ahead and make sure we get these before we start our examples. So basically, the protractor postulate gives us the power to use a protractor to measure angles. And so we can successfully measure the angles by figuring out the location of the two rays and subtracting the difference between them. So we'll practice that in class when we use our protractor. And our final, not our final note, but our final postulate today is going to be angle addition postulate. And so the angle addition postulate is kind of like the segment addition postulate. So here's the angle addition postulate in a nutshell. Given an angle TAM, if you have some point H that is inside the angle, right, inside the interior of the angle, then you can say this is true all the time. So this is how it goes. Given this angle with a point inside, you can say the following. So the measure of angle TAH, that's this guy right here, plus the measure of angle HAM, that's this guy right here, has to add up to the measure of the whole thing, angle TAM. A lot like the segment addition postulate, and we're going to play around with this concept very soon. So turn to your examples and let's get started with example 1. In this example, we're supposed to name 3 angles in the diagram. So there are 3 angles. We've got this one, this little one, and then the whole one. Remember, when we name angles, we're always going to name the vertex of the angle in the center of the 3 letters that we're going to use. So the 3 names we have here would be angle WXY. We also have angle YXZ. And then the larger angle we have WXZ, or angle WXZ. XZ. So those are the three angles we have. That's example one. But look, if we look at angle KHJ, we can see that the angle measure starts at 0 and we can count up until we get here. We could zoom in a little bit so we could see a little better. So you can see that this angle is 55. I start at 0 and I go up to 50 and I see I'm at 55. So I'm going to mark that. So that is 55 degrees and that's an acute angle. The next angle we're looking at is GHK, and that's this one here. When I'm looking at this, I can see that it's obtuse, so I'm going to go ahead and write that down first. We've got an obtuse angle in B, and now we've got to measure it. Looking carefully, we see that we're starting at 0, so I'm going to count out here. Obtuse is going to be greater than 90 degrees, so it makes perfect sense that I get the measure of that angle is going to be 125. Let's go ahead and do the last two. Angle GHJ is a straight angle. You can see we start at 0 and we go all the way over to 180, or we could start at this 0 and we're still opening out to 180. And so that one is pretty clear to see. And so the final angle we're looking at is angle GHL right here. And I think all of you know exactly what kind of angle we're dealing with here. I've got it highlighted in pink. This angle is a right angle. We can see it from 0 all the way up to 90 degrees. And let's get that information written in here. And that's how we would write the measure of angle GHL. Let's go ahead and take a look at the next example. So here in example 3, what we're going to do is find out some information about our angles. First thing we have is that LKN, this larger angle, has a measure of 145 degrees. We're supposed to find LKM, the measure of this smaller angle here, and MKN, the measure of this angle. Let's look at our setup. So the first thing is that these two smaller angles added together will equal this larger angle, and we get that from the angle addition postulate. Next, we're just going to substitute in values. Because we were given these measures, I was able to just substitute it right into the angle addition postulate, and now I'm going to solve this equation. You know how we do. The first thing we want to do is draw a line down to center. This line will represent our equal sign for the duration of the problem. Now we want to simplify this side by joining like terms together. The 2x and the 4x come together to give me a 6x, and the 10 and the negative 3 come together to give me a positive 7. 10 minus 3 is 7, and I get 145 over here. Next, I'm going to isolate the x terms on this side by subtracting 7 on both sides. When I do that, I'm left with 6x is equal to 138. I'm going to divide both sides by 6. After I've done that, I find out that x is equal to 23. So x is equal to 23, but we're not done. That's not what we were asked about. We were asked for the measure of this angle, LKM, and this angle, MKN. So let's go ahead and calculate that. So I know these measures were given. I'm going to now substitute in 23 for the x in place of the values inside the measure. So I'm just doing both of them at the same time. So when I calculate this, 2 times 23 is going to give me 46. When I add 10 to 46, I get 56 degrees. So the measure of this first angle is 56 degrees. Do the same thing over here. 4 times 23 is going to give me, let's see, 2 down there, carry a 1, 8, 9. Somebody did it faster than me, 92. Then I'm going to subtract 3. 92 minus 3 is going to give me 89. So the degree measure of this angle is 89 degrees. And that's how it's done. Let's go ahead and look at the next example. Here in example 4, it says identify congruent angles. And this is a symbol thing, so I want you to pay attention. Trapeze. The photograph shows some angles formed by the ropes in a trapeze apparatus. Identify the congruent angles. And then it says if angle DEG is 157, what's angle GKL? Let's go ahead and pay attention. I'm going to zoom in a little bit to my picture. Your picture might not be as good. It was black and white, I know, but let's go ahead and take a look. Here's what I want you to see. Please observe the fact that this angle here has this double line, this kind of like double line rainbow, and so does this one. In geometry, that means those two angles are congruent. If you want to also notice as well that, let me do this a little bit smaller, that this angle right here has a single archway and this one has a single kind of arch marking, and that means that angle DEF is congruent to angle LKJ. Here's what we were asked though. We were asked if angle DEG has a degree measure of 157 degrees. What about this angle here? I hope you guys can see it. If the angles are marked as congruent, then their angle measures must be congruent as well. So this has a degree measure of 157 degrees. In our final example, example 5, we're looking at a situation where this angle here is bisected by ray YW. And since it bisects that, that means that these two angles are congruent. Notice they have the same marking, a single red line or a single red arch and a single red arch. We are supposed to find, if we know that XYW is equal to 18 degrees, we have to find this larger angle, XYZ. Well, remember we just said that these two were congruent? So let's go ahead and use our angle addition postulate. So the case is that we've got these angles that add up. Smaller angle plus the other smaller angle that's adjacent to it or side by side has to add up to the sum of the larger angle. That's what we've written here. We're supposed to be finding what this measure is, so we are interested in figuring out what that is. We've already been given that this smaller angle is 18 degrees right here. But additionally, these two angles have been created by a bisector, meaning they're congruent. So this has to be 18 degrees as well. When I add 18 plus 18, I get 36 degrees, and that's the measure of the larger angle. And that's it. That's all we got for today. Here's what I want you to do. Ask me any questions. If some of this stuff seems a little bit complicated, we're going to be practicing these concepts in class the next time we get together. I look forward to talking to you soon. Take it easy. Bye-bye, guys.